14.3, Verify Trig Identities. So these first ones, we've kind of done stuff like this before, but it's just doing it in a different method. So 6 says sine of theta equals -7/10. Pi is less than theta is less than 3π/2. So it kind of looks like the problem that you see way over there on the far side of the board that I was doing with college algebra this morning. Other than theirs told them specifically what quadrant. This tells you what quadrant, however, it's not written like that. So I'm going to set this up and see where it falls. Now, what quadrant would this be in? Where's pi to 3π/2? Yep, this is going to be in quadrant 3. So it's going to be down here. So that's my theta there. Now, sine, it says it is -7/10. So what I need to do is I take that and I'm going to do opposite over hypotenuse. So the opposite value is over here. So this is 7 and this is 10. But I have a negative here. How do I know where the negative goes? That's just like, it's like out front. How do I know where it goes? Okay, first of all, can a hypotenuse ever be negative? No. Okay, so immediately I know it can't go on the hypotenuse. But the other thing is, this is like graphing a coordinate, right? Like I'm on a coordinate plane. So isn't y negative down here? So then this has to be negative here. What do I also know has to be true about my x value? Okay, well, it does have to be smaller than 10, but specifically what has to be true about it? It's got to be negative. So I'm going to go ahead and put a negative sign there, and then I'm going to find the number. So what might I use to find the third side? Yep, Pythagorean theorem. So this is going to be a equals the square root of 10 squared minus 7 squared. Okay, so I'm just manipulating the formula to save writing. So this is the square root of 100 minus 49, or the square root of 51. So it's negative square root of 51. Write that a little bigger for that side. And then I'm just finding all 6 trig functions of theta. So sine of theta was given to me. So what would cosine of theta be? What? I can't hear what you're saying. No. Cosine.
Oh.
Negative root 51 over 10. What about tangent? So negative 7 over negative square root of 51. Negatives cancel. I have to multiply by the square root of 51, top and bottom, to rationalize it. So I get positive 7 root 51 over 51. What is cosecant? Yep, negative 10 over 7. And it doesn't matter if the negative's in front or where it is. Secant.
10, positive 10 square root of 51.
So it would be negative 10 over the square root of 51. When we rationalize, negative 10 root 51 over 51. And cotangent. Yep. No, positive. Because they were both negative before. So square root of 51 over 7. All right, another one. 8 secant of theta equals negative 9 over 4. And we're from pi over 2 less than theta less than pi. So, first of all, what quadrant is that in? 2. Pi over 2 to pi is quadrant 2, counterclockwise. So, now, you can do it in terms of secant when we're putting this point on there, okay, if you want to, but if you are like, I prefer to work with sine, cosine, and tangent because that's what I'm more familiar with in terms of like SOHCAHTOA. We can go ahead and set up over here our different trig functions, and I can go ahead and swap secant with what other function? Huh? Cosine? So secant was negative 9 over 4, so cosine is what? Yep. So, I know that this is going to be up here, because I'm in quadrant 2. Theta's here, so where do those numbers go? It's on the x, okay, and yes, it is negative, because this is where x is negative. 9's the hypotenuse. Find the other side. A equals the square root of 81 minus 16. Is that 65? Yes, okay. Yeah. So what is sine? Yep, root 65 over 9. Tangent? Yep, root 65 over negative 4. Cosecant? Yep, the 9 over square root of 65, or 9 root 65 over 65. And cotangent? Yep. And I'm totally fine with you going straight there. I'm just was writing the other ones just for everyone to see it. But
I probably wouldn't want to test
yeah, no, that's fine. I'm also going to say, I have your test graded, so I'm going to give them back to you. Just don't let me forget at the end of class to give them back. But the biggest problem on the ones that you had on your test like this, obviously they weren't these exact problems, but they were similar to these, was a lot of you forgot to reduce. Okay, so make sure you pay attention to that and that you remember to reduce on problems like these. None of these needed to be, but should they have been, we would have done that. Okay. All right, now we're getting into the stuff you have not seen before. Okay, obviously you hadn't exactly seen these, but they were similar. So, simplifying the expression. So we're going to be using those identities that you have in your notes. So you're going to want to be able to kind of flip back and forth a little bit to simplify it down into one single trig function or a single number. So, 10. Sine of x times cotangent of x. So my thought process when I'm doing any kind of simplifying problem or when I get to verifying is how can I rewrite something that I have in order to make things cancel? Okay? So what is one of the things that's in this current problem that I could rewrite, and how would I rewrite it? To think about, like, is a trig function written as, like, or can it be written as another trig function? Or, like, is there, like, a reciprocal identity I can use? Or, I can't think of what they're all called because I don't have them all in front of me, but I know what they all are. Or a tangent and cotangent identity. So basically, can sine be rewritten in terms of cotangent? No, but can cotangent be written in terms of sine? Yes. Okay. What is that identity? Yeah, theta x, whatever.
And then equals cosine theta sine theta.
Yep, cosine. So in this case we have x's, but if you were to switch it to thetas, like, that's fine, or if you want to switch, like, the ones in the notes to x, that's totally fine too. So sine of x times cosine x over sine x, because now I can cancel things. So the sine of x is cancel, and I would be left with cosine of x. So I'm going to tell you, all those identities in your notes, you are going to need to know like the back of your hand. Start memorizing them now. Okay, I will likely give you an identities quiz at some point where you prove to me that you know them. Okay, probably when it gets to a quiz or a test, what I'll do is, much like the unit circle, I won't necessarily be extra credit, but it'll be part of the quiz is you'll have to write them out and then I'll correct them for you. But what I do with these is if you don't know them or you don't attempt to put them down, I don't give them to you. So it's like, with the unit circle, if you just didn't do it or something, I was giving it to you regardless, so you could have just gotten away with it. But with these, I don't just give them to you unless you attempt them. So you're going to need to know them. All right, 12. Cosecant of theta times the sine of theta plus cotangent squared of theta. So what's something I can rewrite here?
Cosecant.
Yep, how could I rewrite cosecant? Yep, 1 over sine of theta times sine of theta plus cotangent squared of theta. So the sines cancel. So I would have 1 plus cotangent squared of theta. And what is 1 plus cotangent squared of theta? Yep, cosecant squared of theta. Do you actually have all those written down? So you did the notes.
I just did them.
Oh. I was like, so you did the notes. Okay. All right, 14. 1, whoa, that's not a 1. 1 plus tangent squared of pi over 2 minus x. So look at what's inside here. Okay, in your notes it would have probably been pi over 2 minus theta. Okay, but this is obviously being squared, so I just need to take that into account. But assume that the squared wasn't there. What would you tell me this is?
Cotangent.
That's equal to cotangent. Okay, so this is going to become 1 plus cotangent, but this was squared, so all I'm going to do is square it of x. So it'll be 1 plus cotangent squared, which we said on the last one was?
Cosecant squared.
Yep, cosecant squared of x. Cosine of pi over 2 minus theta over cosecant of theta plus cosine squared of theta. What can I rewrite here?
Rewrite the top as sine.
Yep. So I can rewrite the top as sine of theta over cosecant of theta plus cosine squared of theta. Now what can I rewrite?
The cosecant.
As what?
1 over sine.
Yep. So sine of theta over 1 over sine of theta plus cosine squared of theta. What is this going to be equivalent to?
Sine squared.
Sine squared, because keep, change, flip. So sine squared of theta plus cosine squared of theta is equal to what? It's an identity.
1.
1. Alright, I'm going to pause before we keep going and make sure everyone's tracking, because I know it's kind of going fast. Huh?
So I'm not tracking.
I see it, but
Like,
it's going to be hard memorizing.
What's not tracking?
so you're just changing things to make it like smaller. So it's like reducing both.
Yes, and I'm going to tell you, there's sometimes you may rewrite something and it not get you to the end result. Okay, with these ones, it's not as bad. But when we get to the ones where it's actually truly verifying, okay, that we know what the end result is supposed to be. And we have to do stuff to get there. And there are some times that I don't even choose the right thing. And I get to the end and I'm like, that wasn't right. And I have to erase it and start over. Okay, because there's different ways we can write things. Like I can write cotangent as cosine over sine, but I can also write it as 1 over tangent, right? So sometimes there's different ways we can rewrite things. So the more you use them, the more you'll start to see what you should use, okay? But right now it's a lot of like trial and error, if you will, because you're trying to figure out how do I rewrite these things to best help me reduce it. Like we're trying to simplify this as much as possible. So we're trying to get one expression like just sine of x or just 1 or just 0 or whatever, you know, it might be. So if you're confused right now, more than likely it will start to make sense after we finish these. I'm probably going to hold verifying for tomorrow because if you don't understand these or like you need practice with these before we do verifying, because if you can't do this, the verifying is going to be more confusing. But we're going to do a couple more. I just wanted to pause before I do the last like 2 or 3. All right. 18. Cosine squared of x over cotangent squared of x. Now, this isn't relevant for this particular problem, but I just want you to see something. Cosine squared of x is equivalent to cosine of x squared, because sometimes you're going to see it written one way and you're going to be like, well, I don't know what to do with that, but these mean the same thing. So that's more of just a FYI for the future, in case you aren't aware of it. All right. So what over here can I maybe rewrite in terms of something else?
Could you write the cotangent square as the 1 over tan? Just square the tan?
So I could, but I want to see if I can rewrite it in terms of something that I already have in the problem, because my goal is to get things to cancel. So that this is one of those situations where things could be written two different ways, but that wouldn't get you to what your end result is
Could you cosine
without an extra step.
over cotangent and have what you have now, and then add cosine squared x over cosine squared x?
No, can't do that. Here, we'll do Tristan's way, because it'll work. It just is going to be an extra step. So we'll do it the way you said, and then we'll go from there.
Oh, I see.
Yeah.
I see. I see.
So we'll do it that way, and then I'll do it the shorter way. So that way you can see that no matter how you do it, it's going to still work. So cosine squared of x over, you said to write it as 1 over tangent, and that would still be squared of x. So then what would I have to do at this point? I have something divided by a fraction, so what would I do? Keep change flip. So this is going to give me cosine squared of x times tangent of x, or sorry, tangent squared of x. Then what would I have to do?
Change the tangent
To what?
to sin over cos.
Yep, and then because it's squared, both pieces are going to be squared. So cosine squared x times sine squared x over cosine squared x. And cosines cancel, leaves you with sine squared of x. So that way worked. Okay, but what's another way I can write cotangent instead of 1 over tangent?
Cos over sin.
Yep. So I can do this instead as the cosine squared of x over cosine squared of x over sine squared of x. Then I keep change flip here. Cosine squared of x times sine squared of x over cosine squared of x. Cosines cancel, leaves you with sine squared. So you're going to get the same thing either way, but this method is probably a little bit faster. Just kind of saves a step. All right, 20. Cosecant squared of x minus cotangent squared of x over sine of negative x times cotangent of x. So there's a lot happening in this problem, right? So I need to try to rewrite things. I need to take something out. For the moment, disregard the top. I'm going to do the top in just a second. Start with the bottom. What is this? Negative sine x. How can I rewrite cotangent? Knowing that I want to see if things will cancel.
Cosine theta over sine.
Yep, so times cosine x over sine x. Which is good because now I see something's going to cancel. Okay? Now on top, what is this, or what does it look like?
1
All right, anytime you see trig function squared, what are we thinking about? It may not look exactly like one in your notes. Or actually, I know it doesn't, but I'm going to show you how to make it look like it. Okay, it looks like a Pythagorean identity. What Pythagorean identity associates cosecant and cotangent, and they always have a 1? What does that identity say?
1 plus cosecant squared x equals cosecant.
Okay. Now, that's obviously not exactly what I have, but fortunately I know basic algebra, okay? And I can move things around to try to make it look like that. So if I subtract cotangent squared here, 1 equals cosecant squared of x minus cotangent squared of x. Oh, now this looks like the top, right? So what is the top? 1. So I just manipulated an identity so that I could use it.
So then you just cancel
So then signs cancel. So that gives me 1 over negative cosine of x, which would be what? Yep, negative secant. All right, I'm going to give you a few for the last 15 minutes or so for you to work on that you need to do before tomorrow, because tomorrow we're going to move into verifying. Verifying, and I might do one more of these that's a little harder tomorrow, but verifying says basically this, it would start you with this, and it would tell you this is, it's going to tell you this is equal to negative secant of x. And you have to get from here to here knowing what the end result is without manipulating both sides. You can only manipulate one. Okay, so that's why I want us to do these now and have them done for tomorrow, so that when we move into verifying, you're at least a little more familiar with the stuff then. So your problems are 5, 7, and then 11 through 21 odd. I'm going to tell you 21 is more difficult, okay? So 21 is what I will start class tomorrow with actually doing, but you need to attempt it before class. Okay, but if you're like, I'm super stuck, because more than likely you will be, then I'll help you.